Hello viewers, this is Ronald taking you through today's tutorial for A-Level Physics, and this tutorial we are going to talk about the solutions for A-Level Physics Paper 1 for UNEB 2019 and particularly question 8. Now where necessary, the following constants can be used. Now these are the very questions I left in the previous video, and I believe by now you've already tried them out and ready to mark yourself and check your progress. So we are going to start with question 8 part A. So question 8 part A, Roman 1 says, what are cathode rays? So shall come and say that cathode rays are a stream of fast moving electrons. So basically that's what they wanted in Roman 1. Now Roman 2 they said, state two properties of cathode rays. So one we shall say that they travel in a straight line, in straight lines. So two we shall say that they cause fluorescence in some substances like glass, and 3 we shall say that they can be deflected by electric and magnetic fields. 4 we shall say that when they strike objects, heat is produced. 5 we shall say that X-rays are produced when they strike matter. So basically that's what we could answer in Roman 2. Roman 3 says, explain two disadvantages of using the discharge tube in producing cathode rays. So one of the disadvantages is that when the cathode rays strike the anode, they produce X-rays which are dangerous to handle. Maybe an illustration of a discharge tube is in this form. This is the cathode, this is the anode, is connected to the pressure gauge and to the vacuum pump. So when the fast moving electrons from the cathode hit the anode, and X-rays will be produced. Then second disadvantage is that a very high PD is needed across the tube, which may not be safe to handle. I think we realize that here we put a high PD, so this high PD is not safe to handle. And 3 is that a gas is needed at low pressure, at very low pressure, which may not be easy to achieve practically. So basically that's what they wanted, and now let's see how marks can be awarded. So correct definition of cathode rays, that is 1 mark, and for the properties any 2, that will be 1 mark. Then for the disadvantages, that's how marks can be distributed. So any 2, that's how you could get yourself the 2 marks. So now shall go to question 8 part B, and part B says that with the aid of a diagram, describe Millikan's experiment to determine the charge on an oil drop. So yeah, so that the setup is as shown. That means that you have to draw the diagram, and this is the diagram you needed to draw. So if you drew it, you can check and make corrections where need be. So after drawing the diagram, we shall now say the separation D between the metal plates P1 and P2 is measured. So this separation D between these are the plates P1 and P2 are the metal plates. So the separation of these plates is measured and given a symbol D. Then next we shall say that oil is sprayed through a small hole in plate P1 by the atomizer. So this is the atomizer, and through this hole in P1, oil will be spread by this atomizer. So now we shall say that an oil drop is selected and observed through a travel microscope when there is no PD, note that word, no PD, between the plates P1 and P2. Its terminal velocity V0 is determined by measuring the distance it falls through a measured time. So you select one oil drop and you measure the distance it falls from here to from this plate P1 to plate P2, and the time is also, and that time is read and recorded. So after knowing the time, you can also get the velocity, because we know that velocity is equal, speed is equal to distance over time. So that we shall say that for known density of oil rho, density of air sigma, and coefficient of viscosity, this symbol, the radius r of the oil drop is calculated from the formula, and that will be the formula 4 over 3 pi r cubed sigma g plus 6 pi, the coefficient of viscosity, radius, terminal velocity, equal to 4 over 3 pi r cubed rho g. So what does that mean? It means that, remember, this was the density of air, so meaning that this will be the weight of the air. 4 over 3 pi r cubed is the volume of that sphere, and this is the density. So volume times density gives mass. Now mass times acceleration due to gravity will give you the weight of the fluid, which is air. Then this is the viscous drag, it is given by that formula, and this one will be the weight of the oil drop. So 4 over 3 pi r cubed is the volume occupied by the oil drop, multiplied by density, you'll get mass, multiplied by acceleration due to gravity, you'll be able to get your weight. So what does that mean? It means that weight of the oil drop will be equal to the viscous drag plus this upthrust on the oil drop. Where g is the acceleration due to gravity. So after that, we shall say that a PD is now applied. Remember, this was done when there's no PD. Now we shall say that a PD is now applied between the plates and varied until the selected oil drop remains stationary. The PDV is read and recorded. So you apply now a PD, you connect it to this PD, and you vary it until an oil drop which has been selected remains stationary. And when it remains stationary, you record the value of that PD and call it V. So after that, we shall say that the charge Q carried by the drop is now calculated from the formula, and the formula is given by Q equal to 6 pi r times coefficient of viscosity times terminal velocity times the separation d over capital V, which is the PD applied. So basically that's what they wanted in this Roman. Now let's see how marks can be awarded. So this one is, that paragraph is half a mark, this paragraph is also half a mark, this one is also half a mark, and terminal velocity is also half a mark. Then all these parameters also have a mark. This equation equating the two upward force equal to downward force also have a mark. Then this applying a PD and select and varying it for the oil drop to be remain stationary is half a mark, and reading of the value of the PD is also half a mark, and full mark for the formula from which you can get the charge on the oil drop. So basically that's how the 5 marks could be got. But if you realize in this question, the question had 7 marks. What does that mean? it means that now the 2 marks were put on the diagram, on the setup. So the setup, what you do, you choose any 4 parts and give each part half a mark, and that's how you could get the 2 marks. Now 2 and 5, that's how you could get the 7 marks which they wanted in this question. So now we shall go to question 8, part C. Part C says that a beam of electrons is accelerated through a potential difference of 1.98 kilovolts and directed midway, note that word midway, between 2 horizontal plates of length 4.8 centimeters and separated by a distance of 2.0 centimeters. The potential difference applied across the plate is 80.0 volts. Then Roman 1, they said, calculate the speed of the electrons as they enter the region between the plates, and they give it 3 marks. So know that the speed, initial speed, is given by the formula 2 times electronic charge times the accelerating PD over the mass of the electron. Now in this question, the accelerating PD was 1.98 kilovolts. So you come and substitute here 1.98 kilovolts and change it to volts by multiplying by 10 raised to the power 3. Now this E is a constant. I think let's do like this. Now this E is the electronic charge and it's a constant. I think, remember, the constant of it in the table of constants, it was given as 1.6 exponent -9. Then this is the accelerating PD, and the whole of this, and it was 1.98 kilovolts. Now we multiply by 10 to the power 3 to change it to volt. Now this is the mass, electronic mass, and it's also a constant. It was given the table of constants at the beginning of this video, and it is 9.11 exponent -34. So when you get the whole of this, square root over the whole of this, you'll be able to come up with 2.637 exponent 7 meters per second, and basically that's what they wanted in that Roman. Now Roman 2, they said, explain the motion of the electrons between the plates. So we have said that the horizontal motion is unaffected between the plates because the net force is 0. The vertical component of the velocity changes with time due to electric force. Then we shall say that thus the electron beam describes a parabolic path. Alternatively, we can also explain it in the following way by saying that the electrons experience an electric force towards the positive plate and move with a vertical acceleration of small e, which is the electronic charge, multiplied by electric field intensity over electronic mass, which is uniform. Then we continue and say that they therefore describe a parabolic path between the plates while the component of their velocity in the horizontal direction remains constant. So basically that's what they wanted in part C in Roman 2. Now let's see how marks can be awarded. So have full mark for stating the formula for the initial velocity, full mark for substitution, another mark for correct magnitude and correct SI unit. So that's how you could get the 3 marks in Roman 1. Now for Roman 2, half a mark, half a mark, half a mark, half a mark, and that's how you could get the 2 marks there. Alternatively, if you wrote this, that's half a mark there, half a mark here, half a mark here, and half a mark here. So basically that's how we could get the 2 marks on any one of the explanations in Roman 2. So now we shall go to 8C Roman 3. Roman 3 says, find the speed of the electrons as they emerge from the region between the plates. So this is an illustration of how the electron will move. It will enter horizontally, but remember we said that the vertical component of the velocity changes with time. That's why you can see it taking a parabolic path within these plates, and after leaving this plate it moves in a straight line. So first of all, we shall remember that the horizontal component of velocity is equal to the initial velocity. Why? Because initially the electron is moving horizontally, therefore the horizontal component is the same as the initial velocity. Therefore we shall come and say that Vx, which is the horizontal component of velocity, will be equal to 2.637 exponent 7 meters per second, which we got in the previous in Roman 1 of this part C. So now we have got the horizontal component of this velocity, but we have not yet got the vertical component. So we shall now come and say that the vertical component Vy is given by this expression V, capital V, which is PD between the plates over the separation, and this gives you the electric field intensity multiplied by electron mass charge to mass ratio, which is electronic charge over electronic mass, E over M, that is the charge to mass ratio. Then again you multiply it by X over U. So we know that the PD between the plates was 80 volts and the separation was 2 centimeters, so change it to meters, multiply by 10 to the power negative 2. Electronic charge is a constant, and it is that. Then electronic mass is also a constant, and it is that. Then X, it was given in the question. Let's see. So in the question we have said that between two horizontal plates of length 4.8 centimeters, that means that now this length, which is from here to here, is 4.8 centimeters. So that means that you will come and convert the 4.8 centimeters to meters by multiplying by 10 to the power negative 2, and this U was the the horizontal component, which is this. Therefore, when I use a calculator, I'll come up with 1.279 exponent 6 meters per second. Now the final speed will be given by the square root of Vx squared plus Vy squared, and when you use the calculator, I'll come up with 2.640 exponent 7 meters per second. So basically that's what they wanted, and now let's see how marks can be awarded. So half a mark for getting the horizontal component, half a mark for stating the formula for vertical component of velocity, half a mark for substitution, and a full mark, whereby half will be for correct magnitude and half for the correct SI unit. Half a mark for substituting the formula for using Pythagoras theory, then another full mark for whereby half will be for the correct magnitude and half for the correct SI unit. So basically that's how the 4 marks could come about in question 8 part C. So I believe you have marked yourself and checked your progress. So what I'm going to do, I'm going to leave you with another essay question for you to try out. So that brings us the end of this lesson. Thank you for watching, and be reminded that the solutions for the assignment left will be available in the next video. So if you have not yet subscribed, please click on the subscribe button below this video so that you will be updated when the video with the solutions has been uploaded. Otherwise, if you also know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we all benefit as a family.